Now, we will continue to one of the most used pre-processing operations, image filtering. Every image contains noise, which can be considered as a random change in pixel gray value throughout the image. It can be modeled as a random variable with the mean 0 and the variance of sigma squared. This random variable is then superimposed to the true gray value of an image. On this slide, a noisy image of an edge is shown on the left. On the right, the profile of an edge extracted from this image is shown. The most efficient way to remove noise is to perform averaging using multiple images of the same scene. However, this is very time-consuming, and in most cases, time requirements of an application do not allow for such approach. On this slide, the image of the same edge as before is shown, obtained by averaging 20 images. You can see that the extracted edge profile is much less noisy. Instead of time averaging, spatial averaging of the image is performed. As we will soon show, this approach is basically low-pass filtering, which leads to the loss of information of the high-frequency changes, for example, edges in an image. On this slide, the image of the same edge as before is shown, obtained by smoothing the image using the 5x5 mean filter. The reduction of noise is obvious. Now we have a task at hand to see how to use filtering functions, low-pass filtering functions, in LabVIEW using the Vision Assistant. We have now here a test VI, which will enable us to quickly test out the Vision Assistant algorithms that we make. So let's put the Vision Assistant right here and wait a bit for it to open. So it will take a bit. And here it is. So, first of all, we need to choose the image that we want to filter. And for starters, we will use an image. This is the image of our School of Electrical Engineering here in Belgrade. This is a grayscale image, and it has superimposed Gaussian white noise. So in order to remove the Gaussian white noise to perform the smoothing, we will go to the processing functions grayscale and choose the filters function. When you choose the filters function, on the left you can see your original image, and on the right you can see the result of the filtering operation. So as we already said, we will first test out the smoothing Gaussian filter, which should be optimal filter for the reduction of Gaussian white noise. So here you can, of course, set up the kernel size, and as you increase the kernel, you will reduce the noise more, but of course, you will lose the information of the edges. The image will get more and more blurry. So let's take it back to 3, and that would indeed be the operation of Gaussian filtering. So now I want to show you another filtering function, that is the median filtering function. And the median filter here, smoothing median filter, with the filter size x and y left, it's a 3x3. So let's click OK. The median filter is not the optimal filter for reducing the Gaussian white noise, but the median filter is the best filter to use when you have an impulse noise, or also known as the salt and pepper noise. So let's open up an image of our School of Electrical Engineering with the added salt and pepper noise. We want to remove the previously acquired images, and here it is. This is the original image with the superimposed salt and pepper noise. As you can see, this is the good part of the image to look at the effects of salt and pepper noise. And after the filtering, using the median filter, the results, as you can see, are excellent. So the median filter is the best filter for the removal of salt and pepper, or also known as impulse noise. So let's click here. We will not change any of the inputs or outputs, and here we can click Finish. So it's creating our Vision Assistant VI. Here we will put the image in, the image to be processed, and here we will connect the destination image, or the processed image memory space, and the image out we need to connect to the processed image, and the original image we will connect here. So let's go back to our front panel, and let's choose, and let's run this VI, and then choose another image, for example Lena, with the added salt and pepper noise. So once again, here you can see the results of median filtering of an image with the added salt and pepper noise. So the median filter is the best filter to remove the salt and pepper or impulse noise. So what if, instead of low-pass filtering your image to remove noise, you want to detect edges in your image? Well, there are functions for that too. Let's use a more appropriate image. Okay, so here it is. In this image, we want to detect the edges of our object of interest in an image. So in order to do that, we go back to the filters function, and instead of the smoothing functions, we choose one of the edge detection algorithms that are available to you in this function in the Vision Assistant. So for starters, we will use the Sobel edge detection algorithm, and as you can see, there are no parameters to vary in the Sobel edge detection algorithm. So let's click OK, and here it is. This is the resulting image of the Sobel edge detection algorithm. So in order to detect the edges of our object, they are brighter now, but in order to detect them, we need to perform the thresholding operation, where we basically only want to keep the brightest pixels in this image. So you can see the histogram of the image, and we want to outline the edges to detect only the edges of our object of interest. If we go too low with our threshold, we will start detecting other edges in our image that are most likely a consequence of noise. We do not want that. So we want to choose our threshold appropriately to detect only the edges in our image. So this is it, and let's click OK. And the LabVIEW has created a binary image where all of the pixels are black except the pixels that are representing the edges in this image that are right here represented with a red value, but the black pixels are 0 and the edge pixels are 1s. Instead of Sobel edge detection algorithm, let's delete the threshold function here. We could use another edge detection algorithm commonly used, and that is the Kenny edge detection filter that is considered to be, by theory, the optimal edge detection algorithm that uses the Gaussian function edge detection algorithm. And here in this edge detection, you could vary some parameters. So there is the sigma parameter of the Gaussian function, and as we increase it, let's increase it a bit, we are getting closer to detecting just the edges of our object that we want to detect. So let's put it at 2.5. And you have another 3 parameters. So of course the window size, we will not be changing that. And you have the high and low threshold of the Kenny edge detection algorithm. So the high threshold represents the percentage of the pixels in the image above which all of the pixels are considered to be a certain edge. The pixels that are below the low threshold in the image are considered to be most definitely not the edge in our image. So that leaves the pixels that are in between the high and low threshold. Those pixels will become a certain edge pixel if they are in contact with any of the pixels that are above the high threshold. Then the program will perform the check again for the leftover pixels that are in between. And the leftover pixels, so the same criterion applies. If they are in contact, again, with any of the pixels that are above the high threshold, they will be considered a certain edge. So the procedure will iteratively repeat until there are no more pixels that are in between and that are in contact with any of the pixels that are above high threshold. So the remaining pixels that are only in contact with the pixels that are below the low threshold will be considered not an edge pixel. So let's play a little bit with the high threshold. Let's say 0.8. Okay, so we're getting closer, 0.9, and let's say 0.97. And as you can see, this does the trick. So the Kenny optimal edge detection algorithm found the edges in our image. It is optimal because in theory it should give the optimal results in very noisy environments, so in images that have poor signal to noise ratio. So let's click OK. As you saw, there are other algorithms for edge detection implemented in National Instruments Vision Assistant, but in this demonstration we will not be considering those.